Okay, so welcome back. Now what we're going to do is introduce the power rule applied to composite functions. So this is also directly related to the chain rule. Okay, so we can look at if we have a function inside of like a power function, then we can use the chain rule, and this leads to us what we're going to call the power rule for composite functions. But it's really the chain rule applied to the same situation. So it says power rule for composite functions says for all values of x for which the derivative is defined, if h of x is defined this way, where we have a function that's raised to a power, then what would we do? Well, the chain rule says we take the derivative of the outside times the derivative of the inside. Well, the derivative of the outside, what are we going to do? We're going to ignore the inside function, and we're going to focus on the outside function, which is a power function. So how do we do that? We use the power rule. So we drop n down in front. That's where we go here. Then we're going to reduce the exponent by 1. That's how we get this. So now this is where the outside function is finished. Then we're going to multiply by the derivative of the inside, which gives us this piece, and we're done. So we're basically just applying the power, the chain rule, right? And so that's it. So we call this the power rule for composite functions, but in reality, you're just applying it. You're just applying the chain rule. Just that in applying the chain rule, you have to also use the power rule for the outside function. And again, there may be other rules and stuff that you may have to use in applying the chain rule. So for example, let's look at this one. So if h of x is equal to this, and so I'm going to write this a little differently. So, oops, no. I'm going to write this as 3x squared plus 1 to the negative second power, right? So instead of writing it like this, I'm going to write it like that, much easier to work with. And now I'm going to use the chain rule. So what I'm going to do is I'm going to focus on the outside function. So in this case, the outside function is g of x is equal, or excuse me, the outside function is f of x is equal to x to the negative second power, right? So we're going to use the power rule. So what do? Well, h prime of x is going to equal, well, we're going to drop the 2 down, or the negative 2 down, negative 2, times, now I'm just going to keep this inside function unchanged, right? So it's just 3x squared plus 1, and now I'm going to reduce the exponent by 1, so that'll give me a negative 3, and now I'm done with the outside function, right? So this is the power rule evaluated at the inside function, g of x. Now I'm going to multiply by the derivative of the inside function. So the derivative of the inside function is just going to be 6x. And so now when I simplify this, I get negative 12x times 3x squared plus 1 to the negative third power. And that is the final result. Okay. Now, normally we don't leave it with negative exponents. We always want to have positive exponents, so we're going to have negative 12x divided by 3x squared plus 1 to the positive third power. So this would be your final answer. And that's it. So we're going to do more examples and we're going to move forward. So this is it. Just again, practice. Have a great day.